Hello again. So this time we're going to be looking at the CO2 sensor again from Sensorion. And as you can see, this is quite a bit bigger. And basically it's sitting on one of the breakout boards that we've put as part of the ESDK or Environmental Sensor Development Kit, which essentially these things all plug in together and give you all sorts of different readings. Now, as you can see, we've put this away from all the other sort of heat sources like the LED and sort of various components like this. But the key thing is with your design is also to look into essentially how to shroud it and make sure that it's reading exactly the right things that you want. So I didn't just create a white cover for this and put it over top. You can see it's got this little square dog collar, if you like, that protects it from any interference going on around it as well and any drafts. So that allows it to basically also not have rays of sunlight hit it, which is also a good consideration as well for the readings. It's worth pointing out that I've actually seen sort of rings and all sorts of products where this is just completely exposed to the air. I wouldn't say that that is, criminal and an absolutely terrible thing, but it is somewhat against the advice and the guidance of this. So it might be worth you benchmarking something with it exposed to sunlight and all sorts of different things which will skew the readings and seeing whether that's actually a problem for what your application is. But if you are trying, as we are, to give essentially an as accurate as possible reading as part of a pollution and environmental sensor development kit, as we said, then obviously those things, that's why we were inclined to give it shrouding and protection. So one of the things that is a nice application of this, and as you can see here, the Good Air Canary reacts especially to CO2 and will basically fall off its perch if it gets too stuffy in here. But it also takes into consideration the temperature and the RH. Now, it's worth pointing out if you think, have I got to build one of those little temperature and RH sensors, which I've mentioned in a previous video. I basically couldn't help myself here, and this is actually one of Sensorion's development kits, and essentially it means that you can sort of plug it in through I2C and take a look at it. And I basically chipped off this little top bit, and it's quite interesting to see that that's the little hole, and then the white thing on top is basically the membrane that essentially allows the gas exchange to take place. And so what's interesting is if you take a closer look at this, you can actually see this tiny little temperature and humidity sensor in what will be the bottom left corner in that example. And so I found this quite fascinating. And then if you look in the top right hand corner, the extremely shiny glassy looking thing almost looks like a bit like a CMOS sensor. That is the infrared sensor that's doing the intelligent bit of taking the readings. So you probably don't need to know that, but I found it interesting just to hack it apart, and it actually gives you some insight into how these sensors work as well. So from a designer's perspective, if you go into Sensorion.com, and again, I should point out that this isn't paid or sponsored by them, but genuinely we've seen many, many good reviews online, and we're no different in thinking these were well priced and nice and accurate sensors for our application to do with environmental sensing. So the accuracy is plus or minus 50 parts per million in typically a range of 400 to 2,000 parts per million. And if you're thinking, why not zero? The reason is that, for example, the background CO2 is just a little bit over 400 and actually has been increasing considerably over the years. If you watch any of David Attenborough's documentaries, it's quite alarming actually how fast the CO2 background level is building up. So nonetheless, as you can probably infer, plus or minus 50 parts per million is really quite accurate for something that is, last time I checked, around the high 20s or $30 type of price range. So this has essentially a slightly slower response time, it's worth noting, because essentially the thing has to allow the small molecules of CO2 to diffuse and exchange. So even though you will get a reading in less than 60 seconds, the more accurate reading will probably need 60 seconds to really allow for that gas exchange to take place. Again, the accuracy in temperature and humidity are a little bit worse than if you have an external temperature and humidity sensor. But of course, these are dedicated within the environment to give you a good sort of parity between the two different sensing units that are going on in that instance. So you're of course welcome to have an additional one, but it's good to know it has one on board as well. So again, we've got a breakdown of all of these things. Again, it works with Arduino and Raspberry Pi type voltage ranges, which is extremely helpful. And even though AB Open did all the clever stuff, I still personally, as someone who works with electronic engineers, keep an eye out for things like I2C interface, which is a nice, should we say, friendly way to integrate it with these sorts of things. I'd point out that there's really, really good technical downloads here on all the documentations as well as the design guide, which I think is extremely helpful on giving you some overview on how best to integrate it. And again, you can probably then look at my design, and the CAD files are available, that we've tried to basically keep it from external disturbances such as sunlight and direct sunlight and having too much wind, avoiding things like a lot of vibration whenever possible. That's why we mount it to the wall rather than leave it on the desk. And indeed, if you were to sort of put it inside a car, this was something that you'd probably need to make sure that you just benchmark and see whether it's having an adverse effect on your readings. So again, I think Sensirion does a good job of giving you sort of not a sort of binary pass-fail, but it's just pointing out what things will be tolerable. So the meh-looking face, and of course the smiley face is what they would really like, but it's also giving you the sad face of what things are really just unacceptable, and you're just going to get a nonsense reading. So it's worth also looking at that for our particular application, we're not looking at particularly turbulent flow, but if you were wanting to integrate it so that it was taking a reading of air flowing either through a pipe or the thing traveling through air, it gives you some considerations and things to avoid as well, which I think is really helpful. Again, the mention of sort of direct sunlight, and you'll notice when you take a look at the enclosure I made, there's actually a good volume of air that can be exchanged, but you can't actually see the sensor very easily, which again hence means that a lot of direct sunlight would be shielded from it. So I hope that's a really useful overview of the sensor and how best to integrate it. And again, whether your projects are outputting on things like the Canary, or whether you're looking at some of the more sort of hot topics, for example, using CO2 as a proxy for COVID, because indeed the amount you breathe out, is potentially proportional to the statistical probability of there being a higher chance of catching COVID. I think this is one of the reasons why certainly these things have been in high demand and certainly gone out of stock more than once, but are obviously, this is a really interesting space for not just makers and amateur enthusiasts, but actually a lot of people in industry integrating these things into, for example, cars, to make sure that instead of thinking that you need to roll down the window, as my dad told me, to change the air so that it's colder to wake me up whilst driving, he wasn't wrong, but it was probably also the CO2 that was building it up and making me drowsy as well. So I think some of these things about our environment, both outside, in our houses, and inside other places where we reside, like cars, these are some really interesting areas to explore with this incredibly small but very exciting little sensor from Sensirion.